Good morning, good afternoon, good evening. My name is Bill Steiger. I'm the Chief Executive Officer of Malaria No More, and it's my pleasure to welcome you to our webinar to mark today, World Mosquito Day. On World Mosquito Day, we don't celebrate the mosquito, we celebrate those who are actively trying to help protect us from the threats that mosquitoes can pose to us, especially when they transmit infectious diseases like malaria. Many of us in the global north view malaria as an episodic kind of problem. It's something we have to deal with when we travel every once in a while to a malaria-affected country. But for those who live in the malaria endemic regions of the world, malaria is a constant daily threat. The statistics are overwhelming almost. 280 million cases of malaria in the last year, estimated by the World Health Organization. 650,000 deaths from the disease, many of them, most of them, women and children in sub-Saharan Africa. In some places, there's a fatalism about malaria. Malaria has been with us for a long, long time, and perhaps people think it will be with us forever, and there's not much we can do about it. But we're here today to tell you that that's not the case. Malaria does not have to be with us forever. And in fact, the three guests we have with us are going to show us three new and very promising, innovative technologies that hold the promise of actually eliminating malaria, perhaps within our lifetimes. One of the things we love to do at Malaria No More is to champion those who are at the cutting edge of science, who are asking questions around malaria that maybe no one else has ever asked before. And our three guests today are three of those remarkable innovators. They're asking questions like, what if we could actually modify the mosquito itself to make it harmless to us? What if we ourselves could be an insecticide? If our blood could actually kill mosquitoes rather than our having to use chemicals out on nets or sprayed on houses? And what if there were another parasite that might hold the promise of protecting us from the malaria parasite in some way? Well, our guests have been working on these questions for a number of years, made incredible progress, and today they're going to tell you about their approaches to trying to protect us from the mosquito. So I'll introduce our speakers and then we'll go through a conversation with each one of them individually, and then we'll have a chance to talk to them, have them talk with us and with you and answer your questions as we move along. So first, Dr. Tullu Bukhari is a research scientist at the International Center of Insect Physiology and Ecology in Kenya, or icipe. Trained as a medical entomologist, she spent over 15 years developing non-insecticidal vector control tools, work that includes her contributions to icipe's Microsporidia MB malaria research program. Dr. Carlos Chaccour is a Venezuelan physician scientist who has been working with the concept of drug-based vector control since 2008. This led to a landmark article in the New England Journal of Medicine just last year, which he will talk about. He's led large clinical trials of vector control interventions in Mozambique, Kenya, and Tanzania, and is currently a resident scholar at the Navarra Center for International Development at the University of Navarra in Spain. And third, Gray Frandsen. He's the Chief Executive Officer of Flyttr, the world's largest biosecurity platform for the development and deployment of countermeasures to the world's most important pest threats. Great. As we move along, if you have questions in the audience, please do submit them through the Q&A function, and we will work them into the flow as we have time. So let's start, Dr. Tullu, with you. Tell us, what is Microsporidia MB and what are its implications for malaria? And I think you might have a slide to help us visually understand what this parasite is and what it might do.
Thank you very much, Bill. So first of all, thank you for the introduction, and also to the Malaria No More team for giving us the opportunity to present the work that we are doing on Microsporidia MB. And today I am here representing the wonderful team that is based at the icipe, which is led by Dr. Jeremy Herron, and also our partners across the world. So I really hope that I do justice with the brilliant work that they do. So coming back to the question, Microsporidia Microsporidia MB is a naturally occurring symbiotic microbe. So it's a microsporidian, as the name indicates, which is a group of organisms quite close to the group of fungi. Now, I have to mention that this is actually a placeholder name, and we are in the process of getting a scientific name for Microsporidia MB. But as of now, and I think still for some time, we will refer to it as Microsporidia MB or sometimes MB, as we have the habit of reverting to. So Microsporidia MB was found in natural populations of Anopheles arabiensis in Kenya, but since then it has been found in several other countries in Africa and in other Anopheles species also. Microsporidia spreads in three different ways. So we have from the mother to the offspring through mating, or through spores. And the spores are released by some of the eggs that Microsporidia MB infected mothers produce. Now, being infected with Microsporidia MB or transmitting Microsporidia MB has no fitness consequences for the mosquito. Now, what is interesting about this microbe? Well, the thing is that when a mosquito is infected with Microsporidia MB, it cannot support the infection of Plasmodium. So in other words, Microsporidia infected mosquitoes do not transmit malaria. And this is something that was shown in the lab. Now, this generated a lot of interest in Microsporidia MB. So over the last 5 years, we have been very busy looking at the various aspects of this microbe. So we've shown that Microsporidia MB is widespread in regions which have very different environmental conditions and also across seasons. We've actually just concluded a survey on islands in Lake Victoria in the Kenyan side. And although the data is still coming in, we have actually found Microsporidia MB on some of these islands too. And while the prevalence of Microsporidia naturally grows up and down over the seasons, it is quite persistent. One of also the unique aspects of Microsporidia MB is that since it is naturally found in the environment, we have already been able to determine that it does have an impact under natural field conditions. So that's a bit of a background of what Microsporidia MB is. So coming to now, the second part of your question, what are the implications of Microsporidia MB for malaria? Well, I'll mention three of them. So the first one would be when Microsporidia MB is deployed, what it is going to do is it will complement the interventions that are already there. And it's going to do that by targeting mosquitoes that we are missing out on increasingly. So the resistant mosquitoes. And Microsporidia is going to be able to do it in a sustainable way. Another implication would be during the pre-elimination stages of malaria, because Microsporidia MB is a self-disseminating microbe. So we don't need to reach every single mosquito directly. If we are able to introduce it into the hotspots and just allow it to spread through the population, it's going to reduce the malaria transmission by those mosquitoes, even as their own numbers are thinning out. And the third implication, I would say, is that because it's a natural system, Microsporidia MB is inherently more acceptable by the communities and the regulators. Yet at the same time, it is a technology which we would refer to as a transmission blocking strategy or a population replacement strategy. And I think this combination can be quite useful because what it means is that the acceptance that we get for Microsporidia MB can also serve as a stepping stone for other similar technologies, which are brilliant technologies. So the experience and the familiarity that would be gained through Microsporidia MB deployment can be used to also build trust and also understanding that is needed for the other technologies. So in short, what we need to do is that Microsporidia is there. What we need to do is just boost it up as much as we can.
Thank you so much. So how close are we to being able to use Microsporidia MB in the field to control malaria? And how do you think it will be delivered or introduced in practice?
So at the moment, we are in phase two of our project or development, and we're moving towards phase three. In phase three, we are shifting our focus to implementation research. So we're looking at optimization, we're looking at scaling this intervention, and of course, we're paying attention to the social, to the regulatory, and also to the economic considerations. So once we've done that, we our aim is to be able to assess the direct impact of Microsporidia MB on malaria in the field. Now, how does the delivery look like? As I mentioned, Microsporidia MB spreads from the mother to the offsprings, from mating, and also from the spores that are produced in some of these eggs. So we are learning from other technologies, and also the wealth of, I would say, operational knowledge that has been generated by the larval control sector. We are heavily leaned towards disseminating spores in the breeding sites, and then let Microsporidia MB just spread on its own with the other two routes also.
We had a question from the audience. I'm going to use my moderator's prerogative to ask you now, which is it quickly, can you explain what we think that the methodology is that the Microsporidium blocks the transmission of the Plasmodium parasite inside the mosquito? What does Microsporidia do that prevents it from passing Plasmodium to us?
So I would say consider it something like our micro gut microbiota. So there's not one way. It's not very clear how this. It's a spectrum of effects that helps that microbiota now to make us much more stronger. So the Microsporidia is kind of in a similar way. It makes the mosquito able to inhibit the Plasmodium from developing in it. We've done research. There's no one mechanism, I would say. So we've seen some effect in terms of the metabolic genes, but also the immune responses that help kind of support inhibition. So there's no one single mechanism that I can mention here.
Fascinating. That's just amazing. So to close our first part with you, what do funders and policymakers need to support now in order to accelerate this amazing research and development?
Thank you, Bill. So that's a great question, and I think it's really relevant to the stage we are in our project and also the general funding environment that has been there. So with funders, it's pretty simple. So it's like supporting funds, giving us funds, supporting us through this stage of R&D that we are in, and for R&D to go efficiently, what we need is that we need to be able to retain the capacity that we've already built, but also to be able to partner with organizations and also institutions that already have expertise that we can now leverage to fast track the development of Microsporidia MB. And as I have mentioned many times, the tools take quite a long time to develop, but I think we're in a good state now with all the latest technologies and AI. I think it can be fast tracked to quite a degree. Now, when it comes to policymakers, well, they need to ensure that there is consistent funding for R&D on public health issues in general, but also for malaria. And that technologies like Microsporidia MB move through the regulatory pipelines and actually do reach the people that are carrying the disease burden. And while this is happening, that they ensure there is equity, they ensure that there is fairness. So we build capacity locally, and the work can go on now sustainably because there is capacity in the regions that are most affected by this disease.
Wonderful. Thank you so much. We'll come back to you after a little bit. So, to you, Dr. Carlos. One of the things I've learned as I've taken on this role is the very interesting phenomenon that it appears, you can correct me if I'm wrong, that in some places, even with very high coverage of bed nets and usage of bed nets and the availability and access of other tools, that malaria continues to be stubbornly persistent and prevalent. There is what I think you're going to tell us is a phenomenon of residual transmission of malaria. So what is that? And how does ivermectin potentially help solve this problem? I think you might have a slide too to start
Yeah.
us with.
Well, thank you so much for the invite. It's a pleasure to be here, and I'm also will be presenting the work of numerous people. We had a huge consortium with more than 80 institutions, and at some point we were 400 people. So we're grateful to all of them, although we cannot really name them independently. Um, I would start by saying that I worked for several years in a district in Mozambique called Mopeya, which had both bed nets and indoor residual spraying. The coverage was acceptable for both. IRS was taken care of by the President's Malaria Initiative, and alliance distribution happened both through the PMI and local channels. Coverage was about 77% of bed nets. IRS had about 80%. So we have a district with two core vector control tools, and we still found 60% prevalence in children under 5 in this area using RDTs, which is a very basic level to look at malaria. So if you actually look at PCR, for example, you could really expect very, very high numbers of prevalence. And how do you explain that? Well, because not all mosquitoes are equal. Like mosquitoes, traditionally, the most effective vectors feed on us when we're asleep at night. That's when we are more vulnerable. That's why bed nets work so well, because they offer a barrier and they also have a mass effect killing these mosquitoes. But then in Spanish, we say to die of success, right? And I think that's also part of the problem with bed nets. It's been so successful. We've deployed more than 4 billion bed nets over the last 20 years. That has half malaria deaths. That's an amazing success. But a very nice phrase from Jurassic Park is that life finds a way. So if you become really good at killing mosquitoes that feed indoors at night, then there are cousins who behave differently and they like to feed outdoors or at dusk or dawn, or go feed on your cows and your sheep and then come back and feed on you after that, have an advantage. So we have effectively shifted malaria outdoors and outside the middle of the night to temporal and spatial gaps that are not protected anymore. And that leads to this phenomenon known as residual transmission, which is what we see on the screen, right? You have, even though lots of people are protected, some of the behaviors of these mosquitoes, which doesn't have anything to do with resistance, which is a different problem, then contribute to sustained malaria, even though the coverage with our current vector control tools can be excellent. So that's what I think ivermectin could help address among many of the tools that are being developed, right? We need a tool that can work outside, indoors and outside the middle of the night. We need to start filling these gaps that are left by our current vector control tools.
So you mentioned at the beginning your consortium, Bohemia, that has involved, as you say, hundreds of people, been working in Kenya and Mozambique, generated very important field evidence. So tell us what the trial showed, or trials showed, and what questions still remain to be answered.
So ivermectin has been in use by humans for more than 30 years, right? It was developed as a veterinary drug by Merck to treat both parasites that live inside the body, endoparasites, and parasites that live on top of the body, so ectoparasites. And it was a blockbuster drug. It quickly became a 1 billion seller a year in the veterinary world. And then it was quickly adapted for human use in the 80s to tackle a very different disease, onchocerciasis or river blindness, which was really leaving phantom villages in West Africa. And it's been used for river blindness and then later for lymphatic filariasis for over 50 years, for over 30 years, because Merck donated this drug for as long as needed to as many people as needed until those diseases are eradicated. But ivermectin also kills the mosquitoes that feed untreated people, as long as the drug is still present in the body over a certain threshold. So this offers the advantage not for a sweet revenge, which we all like, but the idea that if you treat massively a community, then you break those barriers of time and space. So if a mosquito bites you outdoors, if a mosquito bites you at sunrise when you're making breakfast, you can still kill this mosquito. This mosquito will not go and feed on your neighbor and will not go and feed on your children. Plus, ivermectin brings all these other plethora of benefits by getting rid of several of your intestinal parasites, getting rid of your scabies, your head lice, your onchocerciasis, your lymphatic filariasis, and your bed bugs. So what you have then is an opportunity to distribute this drug massively, as it is already for neglected tropical diseases, and then add one more target, which is malaria in this case. So communities could benefit from an integrated approach to malaria and entities. Uh, what we tried to do is that we looked at giving all the community a single dose once a month for 3 months, 3 consecutive months during the rainy season, both in Mozambique and in Kenya. And what we showed in Kenya was that a single dose of ivermectin, not very different from the ones used for entities already, given once a month for 3 months, would reduce malaria on top of bed nets. And in Kenya, we had 80% coverage and 80% usage of bed nets. So very good coverage. So this distribution on top of that reduced malaria by an extra 26%. Not only that, but people were super happy about the bedbug reduction. And then in Mozambique, we showed that scabies and head lice were reduced by 80%. The malaria effect could not be measured appropriately in Mozambique because we got really hit by the Gombe cyclone that really disrupted the whole implementation in 2022 by flooding the south of the Mopeya district, by fueling cholera epidemics. So the coverage was very low as compared to what we wanted to achieve, and the operations were really disrupted. So, but in Kenya, we really had good data. The team at KEMRI did a fantastic job and proved that a single dose once a month for 3 months could reduce malaria on top of bed nets. Questions that remain. Well, there is need for at least one confirmatory trial that looks at this question in a different eco-epidemiological setting, ideally in West Africa or a different area that is not coastal Kenya, to show that this was not just that somebody got lucky or that the weather was specific. There's also things that I am interested on. Initially in Mozambique, we really wanted to treat not just the humans, but also the livestock in the area, because as I mentioned during the residual transmission, cattle and goats do not host malaria, but they provide a free meal to these mosquitoes because they normally are not covered by insecticides. So if mosquitoes go feed on them, that allows the population to thrive. So if you also treat not just the humans, but those animals, then you're leaving the mosquitoes less and less option for blood feeding, not to mention a fantastic benefit in terms of food security, because if you treat those goats and you treat those calves early on, they grow faster, they produce more milk. So there's an additional economic benefit for those households. So questions that remain, it's one of those is how can we explore this One Health concept further? Can we reproduce this in a different eco-epidemiological setting? And then there's a lot of interest in long-lasting formulations, so you don't have to repeat this dosing once a month. You can just give a single shot, and that would cover the whole rainy season. And there's people working on all three of them.
Fantastic. A question from the audience that's, I think, relevant right now. Have you seen any evidence of resistance to ivermectin among the parasites in the trials or
Among
the mosquitoes?
among the mosquitoes, well, it's interesting because ivermectin has been distributed for 30 years. And what we've seen is that the mosquitoes are exposed to ivermectin in the field are dying still much faster than those that are unexposed. So resistance is a phenomenon that is unstoppable. We really need to manage it proactively and think about it ahead. Anything that we develop will eventually face resistance. So what we're trying to do is develop tests to look at how resistant would look and to see how we can address it. But ivermectin is very different from any other insecticides that are used today. So we have hope for that. And what we have to do is monitor closely and pay attention, just like they did during the onco control program in West Africa in the 70s and 80s.
Wonderful. Thank you. So you touched on this, but maybe expand for us, if you could, on the point of how the distribution of ivermectin might be integrated with other interventions. So could it be done alongside routine vaccination? Could it be done alongside the distribution of bed nets? Could it be done alongside, as you point out, drug administration for other tropical diseases? How would you see in practice that one could, especially if we're for a while going to be using monthly doses, um, integrate the distribution of ivermectin in a way that would reduce costs and expand coverage and not prove an additional burden to a healthcare system?
That's a great question. And before you ask what questions remain, well, one of the key questions that remain is, can community deliver this monthly for 3 months or maybe 4 months? Because communities have extensively proven that they can do it once a year for onco and LF. And basically, we have reached a point in which the drugs are given to the community and some minimum training is provided, and then it's a community directed process. And that provides a sense of ownership, and that provides commitment, and that, yeah, this idea of empowerment. So one key question here is, can we leverage that system and expand it to 3 months or the rainy season? I think that's a very good question for research right now. The distribution of ivermectin alone will target many neglected tropical diseases, and then adding on top of that a different dewormer like albendazole would broaden the spectrum. Adding an antimalarial would definitely make the impact of ivermectin stronger. And once you put together such an effort to distribute a drug, either community centered or community delivered or community or door to door, then it makes absolutely a ton of sense to leverage that effort and then piggyback on top of that BetNet distribution, vaccines, vitamin A, all other sorts of efficiencies that can really help this. So we really have to look up to the entities models of distribution. What I would say we cannot look up to is the entities model of financing, because ivermectin and onco and LF is based on a huge donation program, which has been really generous from Merck. Ideas of visionary leadership team in the 80s, Dr. Vagelos and all the people back then. But I don't think it's fair to expect that industry will continue to expand donation to an ever-growing number of indications, right? So there is a need to find a sustainable finance model if ivermectin is going to become a malaria a tool. So there will need to be inclusion in multilaterals, in bilaterals, and in national funding.
Good. Last question for you before we go to Gray, and we'll circle back because there are some questions directed at you in the Q&A function. And I'll remind the audience, please do use the Q&A function, not the chat, for questions if you can. What are the next regulatory and policy decisions needed for ivermectin to become a routine part of malaria control?
So there's still work. There is one very good trial that provided evidence. There is one disrupted trial. This is ivermectin alone. And then there's a group of other trials that looked at ivermectin in combination with other things, such as SMC or mass drug administration of an antimalarial like the icipe paraquine. So that's great, but the problem is you cannot really mix these trials in a meta-analysis because they use very different interventions. So there's one meta-analysis that is ongoing by Cochrane and should be ready soon. And I believe is going to say we don't have enough evidence yet. So definitely the next step is going to be reproduction in a different epidemiological setting. Plus, there's this ongoing work on long-lasting formulations, which I think make it very attractive. And then the usual when you want to have a guideline that is issued by the WHO, which is a very good guidance for countries to implement or not, but saves the countries time and effort, is to look at efficacy, safety, cost effectiveness, acceptability, and then programmatic suitability. So all those 5 have to be studied in trials, ideally in the following trial, to actually provide the data needed for an evidence-based decision on this.
Great. Thank you so much. Gray, we'll turn to you. Talk to us about some other kinds of mosquito technologies, the ones you've been working on. Can you give us an overview of the big innovations that are coming from biological solutions like self-limiting mosquitoes, gene drive technology, and how are they useful against malaria?
Good. Yeah, thank you, Bill. And I find this conversation fascinating, taking notes from the 2 previous guests. Well, first, I do represent Flyttr, which is formerly known as Oxitec. We have been around for over 20 years, and I represent a team from 15 different countries, amazingly passionate and ferociously mission-driven. So I'm very excited to be here and talk about their important work. I am excited about a few big things, and I'm not going to go too technical here because I think there are some big themes that our public health community is chewing on or dealing with, and I want to get to those. But here's what I'm excited about. First is the evolution of the power of biology and the ability for us to make helpful adaptations to mosquitoes to enable them, malaria-free mosquitoes, to be used in mating-based technologies to suppress a population or alter a population for public health benefit. The evolution of this practice of the use of using insects to fight insects, remarkably, is more than 70 years old. And I'm in the United States today, where we're suffering from an incursion from the New World screwworm. The US helped eliminate this pest 50 years ago using mating-based technology, sterile insect technique. A lot of folks don't appreciate the fact that communities have become not only used to these types of technologies, but actually desirous of them. So today, with the power of kind of biological engineering, we have the ability to build on that legacy of success. 2 big things I'm excited about specifically in the malaria space include self-limiting mosquito technology. So Flyttr is the pioneer in developing mosquitoes that, when released, male mosquitoes that don't bite, when released, mate with wild-type females, and all female progeny die. We have a few variations of that theme, but we're now developing malaria vector solutions that dramatically and very specifically suppress a disease-transmitting population of a specific species. I'll talk about Djibouti a little bit later and the exciting work we're doing on Stephen's eye, or Stevensi. There's the debate. And really the promise of these targeted suppression technologies is proven. And we'll talk more again about what we're doing in different countries, but very exciting to be able to have a technology that you release and that targets the species specifically and dramatically suppresses population. The other bucket of technologies that we're excited about is gene drive. And I'm sure that many folks on this at this event understand or know what gene drive is. Um, and um, and we think that gene drive is going to play an outsized role in kind of a future where malaria can be eliminated. And I hope malaria is eliminated in our lifetime. Gene drive, of course, being a technology that also uses helpful adaptations to a mosquito's biology that helps push, in essence, a genetic payload or characteristics through a population to achieve an end. And there's an incredible body of work being done from a number of organizations, and we're really happy to see our brothers and sisters in those organizations do such great work. So if you back out, though, really, I think I'm excited about all that, but I am very concerned, very concerned about the pace at which these technologies are being regulated and in essence, prepared for scale. And we just heard from these two wonderful experts about the challenges of moving an innovation from the lab to implementation or intervention. And I'll tell you, Bill, the work we are doing, the tools we now have in engineering of biology are improving at a rate of, a pace, in essence, that is outpacing the ability for governments to regulate these technologies. And arguably, regulators now today are evaluating technologies, some of which are now 10 years old. So imagine how far we've gone. Lots of excitement. Can we operate and can we deploy these technologies at a time scale that matters? That's the kind of other side of the ledger, Bill.
Thank you. And we'll come back to the regulatory point in a second. For the benefit of some of the audience who might not be aware, you mentioned it, the Anopheles stephensi or Stephensi subspecies, originally from South Asia, has migrated into East Africa. Djibouti is the place that it was found first and from which it is now disseminated to a number of countries all the way across to West Africa. It's different because it bites in the day, it lives in urban areas, it can live in dirty water, can live at higher altitudes than some of the other species, and appears to have a profile of resistance that makes it very dangerous. So it's changing our assumptions about what's possible and challenging a number of the tools that we have. So talk to us about how you got involved in this work in Djibouti, what you found, and where else you think your technology, that now that you've tested it, might make the biggest difference.
Yeah, great question. Thank you. If there was a poll feature on this Zoom apparatus, it would be great to get a poll about whether it's Stevens eye or Stevensi. We deal with that every day, all day long. We got into the race to control Stevens eye at the request of the Djiboutian government. So this is an African government that was on the front lines, literally, in East Africa, arguably the gateway for this vector to come in. And it was a remarkable and devastating story that Djibouti shared with us, which is a handful, literally, a handful of cases representing their incredible work to control malaria was reversed in a very short time. So near elimination, and all of a sudden this incredible spike and suffering of the Djiboutian people. They called us because, in part because of the fact that there were no other effective means of controlling this vector. Daytime biting, you mentioned, kind of makes bed nets far less useful. The resistance load in the subspecies that have come in suggests that they're highly resistant to virtually all known chemical pesticides that could be or would be used. And they were desperate. And so they came to us and asked, would you build a friendly Stevensi technology for us and move it at an incredibly rapid pace, do it in partnership, and begin deploying on their soil? And the answer, of course, was, you bet, let's do it together. So for a number of years now, we've been working arm in arm with the Djiboutian government, led by incredible public servants and visionaries as it relates to how to create an integrated program to control malaria, now embedding these new technologies that give them the ability to envision superior vector control relative to what's available today. So it's an incredibly wonderful story that was born out of a very difficult development. They are still suffering from malaria. So we're not out of the woods. We are still in pilot mode. We're moving into our third field season. Of course, this is the continent's first release of a product-oriented strain. Other GM mosquitoes have been released, but in rangefinder mode, we're now demonstrating suppression with the form factors that we anticipate moving into the field as soon as we can. I'll say another quick note, when governments lead, great things can happen. And I think what Djibouti has shown is that when you align a need, a willing government with an open mindset and with an innovative bias or a bias for action, combined with innovators that can move very quickly with the best tools available today, we can do really great things. Big question here is, can we demonstrate nationwide in Djibouti an incredible result that we're proud of in a timescale that we're proud of? And how quickly can we make this technology available to the next set of countries with whom we're already engaging?
One of the things that you and I have talked about before and that you announced in May was a move into Uganda and the creation of a new research platform there. So with that move, you found, I think, another willing government that wants to be on the cutting edge and to move very quickly. But what are the main regulatory barriers, the challenges in community engagement and public trust that you've found that you and others need to overcome to make sure that these technologies can get out into the field much more quickly? And how are you solving them?
That's right. Yeah. Well, I believe your staff have a slide to share. Let me start with, again, a bit of history. I mentioned the use of insect-based, mating-based technology for 70 years. We've been doing this for more than 20 years. We have been not only developing these technologies, but deploying them in partnership with governments around the world. And I think a lot of people don't appreciate, first of all, the body of evidence from a scientific basis that we've been able to generate, but also the body of trust we've been able to build with every community we've sought to serve. So there's just a couple of snapshots here from Flyttr's experience, and because we've been the first for GM insects in the world everywhere we go because we're first. You can imagine that the burden is on us to build trust with the communities we seek to serve, and we have done that. A couple of principles. Well, here we have Brazil, we have Florida, the Marshall Islands I've included here. It's a wonderful story of what's happening today, right now. Djibouti I just talked about. But placing this into the frame of the fact that we are building technologies to serve humans. We are trying to kill mosquitoes and a very specific species of mosquito wherever we go. And we're doing it in a way, and I tease my peers at the big chemical companies, we're doing it in a way that inspire people to participate. And I would challenge my counterparts at some of the other big chemical companies to show me communities that would love to wear their T-shirt or have their logo stamped on their hand or coming around to sing songs and celebrate the deployment of these technologies. It's remarkable, and I'd welcome anybody who's interested to learn more about this with us. Come see us, take tours. We just love it. So, point is, for 20 years we've been doing this. This is not new. GM mosquitoes are not new. We have released billions of them worldwide. And we've built trust everywhere we go. It starts with invitations from government. We don't go anywhere we're not invited. It starts with being present, being purposeful, being transparent, and ultimately, inclusive of what's important to the communities. So, having done that, let's now talk about policymakers, because that's where I spend a lot of my time in capitals, thinking through with government and policymakers, and applying to policymakers or regulators. So let's start with policymakers as separate from regulators. I think elected, need to be mindful, but we need elected officials to think boldly and act prudently, but boldly, with ambition. If we are going to see the end of malaria in our lifetime, we have to change what's happening now. We have to change the timescale at which things are happening. My team is going to build the technology capable of eliminating certain of these challenges in the malaria space. Not alone, and not all of them, of course. And we need policymakers to appreciate that and to set the political and regulatory frameworks that will allow responsibly developed technology, well-worn, well-proven, to move through systems to get it. And Tulio and Carlos talked about the exact same things. They have the same hill to climb when it relates to getting policymakers' attention, focusing them on appropriation, so there's funding, and ultimately creating frameworks for success. We're not moving fast enough. So in Uganda, I've met with President Museveni a few times. Political leadership in Uganda is supportive, and there's a long and rich history at UVRI. Maybe there are some folks on the call from UVRI. They just celebrated their 90th anniversary about a month ago. We chose Uganda partly because I've been going to Uganda for 24 years, not to age myself, but it can serve as a wonderful place where we generate, in partnership, we generate a place where innovation can happen, where policymakers and regulators from the region can come and interact with innovators, with entrepreneurs, with the technology, and where we can start to envision the industrialization of these technologies, because we haven't talked about what happens after a regulatory approval happens, and we're demonstrating what that looks like in Brazil. Large-scale commercialization of GM insects right now is happening in Brazil. We're selling into every state in Brazil, GM insects. Regulators, incredibly professional worldwide. We rarely meet a regulator who is not ready to dig in, ready to engage on the merits, ready to base evaluation or risk assessments on strong scientific underpinnings and benchmarks or gates through which developers must pass. But the challenge we found, and this is not new, again, the challenge we found is that simply there's an absence of regulatory frameworks in a number of countries that can really use these technologies. So policymakers and regulators must work together. We must work collaboratively with both communities. And I think all of us need to impress not only on ourselves, but on decision makers, the fact that paperwork should not prevent us from saving lives. And arguably, we're seeing that in a number of areas of innovation. So there you have it. That's my view.
Thanks, Greg. So as moderator, I'm going to ask each of you the same question before we turn to some audience questions. The quick question, building exactly, Gray, on where you left, was what is the one decision that a funder or a policymaker could make right now that would most accelerate your technology? So Dr. Tullu, I'll start with you.
Thank you, Bill, for the question. So at the moment, compared to the other technologies that the other panelists have discussed, we are at quite an earlier stage. So for us, R&D is key. Funding for R&D, consistent funding for R&D. That would be my short answer.
Great. Dr. Carlos. I think you might be muted.
Yes.
The fastest thing would be a second trial with the oral dosing in preparation for the investments that have already been made in the long-lasting formulation. So ideally, there would be a oral dose trial conducted in the same area that is being targeted or considered for the long-lasting intervention. So that prepares the population, shows the benefits, etc. Great.
And Gray.
I assume we can't use our one wish to ask for more wishes. So what I would argue is from donors and policymakers that we gather every important policymaker and regulator in one room, feed them, and really argue that they shouldn't emerge from the room until they've engaged in a discussion around harmonization of regulatory systems. Harmonization of regulatory systems, how can we begin setting standards that can be shared across countries, across regions, so that technology developers, not just us, but others, can see a clear path, can organize capital, philanthropic or otherwise, and can put teams to work knowing there is a well-worn path or a path that will allow them to see impact with their work. There you have it.
Wonderful. Thank you. So some questions for the audience. I'm going to take one for each of you, and then we'll see where we stand after that with time. So, Dr. Tullu, first back to you. Are you looking for and are you looking at solutions to scale the production of the Microsporidia MB and its delivery? What does that look like in your mind to go from smaller growth in labs to mass production of the parasite and its spores?
Yes. So indeed, this is what we are looking at. That's our immediate interest at the moment, scalability, producing mosquitoes in high enough number to be able to have spores. And then, of course, when it comes to the spores, we're also looking at the stability of those spores, the shelf life of those spores, formulation. So this is where we are heading towards and is our priority research area.
Wonderful. Thank you. Dr. Carlos, two related questions for you. Can you talk about cost? What does a 3-dose or 3-month regimen of ivermectin cost roughly? Does it require cold storage? And what is its shelf life?
Right. So it does not require cold storage. It's been used in Africa for more than 30 years. The shelf life, it's up to 2 years at 37 degrees. With the current formulation, it can be explored further. And then the costs of the current, the way it's currently used, the cost of delivery is higher than the cost of pills. The cost of the API, of the active pharmaceutical ingredient of ivermectin, is less than cents per pill. We have a whole cost effectiveness paper. I put the link on the question, and we estimated around 45 cents per dose per person. So that I hope that answers the whole 3 points.
Perfect. That's wonderful. Gray, a question about your releases in Djibouti. What are the challenges that you've seen in ensuring that your released males are competitive with the wild males under field conditions? How do you make sure that your mosquitoes win?
Great question. We spend a lot of time and energy on this. And one approach, of course, that we've done in a number of areas is crossing into a local strain, so that we're in essence harmonizing, and that's a relatively normal process. But the question is a good one. How do we ensure the effectiveness of a product? Let me just stretch it to what Carlos was talking about, likewise with Tulio. When we think about economics for these technologies, these are exactly the type of questions that we have to ask and solve for. If our males are not as effective or competitive as local wild types, we have to release more of them. If you have to release more, it's more expensive. And pretty soon you begin moving yourself up a curve that makes the technology not accessible. So that is one very good anchor question that we like to solve.
Thank you. Dr. Carlos, a question back to you about the rainy season or seasons and their now variability. They're perhaps not as happening when they used to or as predictably as they used to. So how are you thinking about adapting the current single dose per month strategy with ivermectin to the shifts in timing and duration of peak transmission after rainfall begins or after rainy season begins? And I know you talked to me about this one at one point the last time we spoke. How do you have to time the administration of the ivermectin to rainfall? How far in advance do you have to start? And talk to us about that relationship, especially as the periodicity and the duration of rains might be changing in a country like Mozambique.
This is a great question. So beyond using a crystal ball, what you do is you look at the average start of the rainy season in the previous years, and you have to target the very early start. Why the very early start? Because once there's a lot of rain falling, a lot of mosquito reproduction happens, and that's exponential. So if you come too late, let's say a month and a half or 2 months after the rains have started, then suddenly ivermectin is fighting a raging fire rather than just something that is beginning, and it takes much harder efforts to stomp it out. So there's two ways. You can go beyond the 3 doses. In fact, I've been asked before if what I would change. Well, I would do maybe 4, hopefully 5 doses, and I will try to start earlier than we did. So you don't have to really time it perfectly. You can try to start at the end of the dry season, and these 5 doses would for sure give you coverage in an area where the rain season is 3 or 4 months. If you have a longer rain season, then you can also add additional doses, provided that the communities can deliver or your distribution budget holds. And then there's also, everybody has hopes for these long-lasting formulations because they could give you months of coverage with a single encounter with a subcutaneous injection that is similar in volume to a vaccine. So though that's the answer. Higher number of doses, trying to start a bit earlier, and then potentially look at a long-lasting formulation.
Fantastic. So a question now for all of you, or any of you, I'll pose it to the whole panel. It's about resistance. So speaking both of your own technologies and those that are also out in the market or in development, things like next generation bed nets or the vaccines that are now in use or being developed, which do you think, and maybe what combination perhaps do you think has the greatest potential to overcome the growing resistance that we're seeing both of the parasites and the mosquitoes?
Okay, I'll give you my thoughts. I think we need to have a really big toolbox that allows for policymakers and people leading the programs in each country to say, all right, in this area, I would like to choose this, that, and that. Right now, we have a very limited toolbox. So we really have to expand that toolbox, and we really need to think of layers. We cannot think anymore of silver bullets. During COVID, there was this very famous diagram of the Swiss cheese. Probably many of you saw it, in which you have imperfect layers, all with holes, but then all together really stop the transmission. So I think malaria, we will need to pivot from, hey, bed nets for everyone, to there's a big number of tools and we layer them in like a Swiss cheese to acknowledging their imperfections.
Gray or Dr. Tullu?
So I completely agree with Carlos. I think, as you said in the beginning of this meeting, malaria has been there for a long time, mosquito for a way longer time. There is definitely a chance that we will, there's no tool that we can be 100% sure that resistance will not develop against it. The pace of resistance might vary, but mosquitoes will find a way around it. And there's, so it needs to be a toolbox, but I think we also need to highlight here that as we are developing these tools, we're also looking at how does this tool work with the background of other preventive tools also. So we know that which combinations of tools will work together and which will not work together.
Thank you. Gray, any thoughts?
Integrated tool. Agree with everything that they've shared. That's the short answer. And as we generate more evidence for some of these species-specific targeted technologies, I think we can begin envisioning the chemistry or the mix of things that can come together for elimination. I will say, I don't think between technology developers or classes of technologies, we don't talk enough. We don't talk enough between each of the innovation communities that make up the pursuit of the end of malaria. we're definitely guilty of not being more curious and more outreaching to other innovation communities. But to the point that the two have made here, we need to have a big toolbox. Um, but I think increasingly we're going to have to insist that technologies work well together. And how do they work well together? How do we package these things together? And I'll finally, just not to harp, 7 times on the call, Bill, but the timescales that we're working on are not harmonized. Technology now is moving far faster than the outer rings of slower moving reg and policy making. And I think any toolbox for now is going to be hindered until we start to harmonize the timescales.
Absolutely. So we have a couple of minutes left, and I want to ask you all one more question, a rapid fire one, which is if we were having this conversation 4 years from now, it's 2026, now we're at 2030, what would success look like for your innovation? And Dr. Tullu, I'll start with you.
Thank you, Bill. That's a very interesting question. And so I would say, well, first of all, we won't be saying Microsporidia MB anymore. We'll be using another name for it. And but what success would look like for us. So it's a bit of what I answered to one of the questions in this webinar. So it's a spore-based formulation of Microsporidia, which is stable, which is scalable. But in addition to that, we've passed through the regulatory framework. So we have approvals in our hands. So we're not saying, can we deploy this? But we are now really generating the real evidence of impact that introducing Microsporidia is doing on transmission or the disease burden in the community, and that we are doing this at a reasonably meaningful scale. And just as important is the capacity to do this work, the science, the manufacturing, the regulatory expertise. Seeing that there is capacity built and the work is being led by researchers in regions which are most affected by that disease. That would, for me, be a very successful 4 years.
Fantastic. We hope it takes less than 4 years, right, Gray? Dr. Carlos, to you, 4 years from now, what does success look like for ivermectin?
There is another trial with an oral ivermectin that has finished maybe 6 months ago or a year ago, and it has produced good evidence. There's also been a very good exercise inquiring whether communities could deliver this, and that has shown that people can do it and communities can be empowered to do it. And that has led to at least one large-scale programmatic level implementation as a pilot in a district. In parallel, there would have been work on a long-lasting formulation. The first in human would have happened already and would be really in the depths of planning the phase 3 of the long-lasting.
Fantastic. And Gray, I know in your mind, 4 years is a lifetime. So where would you like to be 4 years from now?
Yeah, I think, of course, Flyttr and other of our peer groups are deploying billions of mosquitoes worldwide to solve many of these challenges. That we would love that. We're going to get there. I think the big wish here in 2030 would be that a market is formed. A market is formed for new innovations because we have found that the more organized a market is for a particular set of interventions, the faster things move. And arguably, right now, the market space for innovations in vector control is very, very fragmented. It's and arguably not organized, which makes it, again, difficult for innovators of any type to raise funds, build stuff, move stuff, and save lives. So please, may I have a market by 2030.
Fantastic. Well, thank you all. This has been an incredibly educational and illuminating and inspiring conversation. I hope for everybody here on World Mosquito Day that soon these technologies will be in wide use in the field, and then we're going to be making progress against the challenges that we identified around resistance, around this Stevens eye species. And I will leave the audience with two takeaways after thanking them and thanking our panelists for lending us their time and their insights today. One is that I very much hope that everyone comes away with a sense of optimism that the science that you've heard about, the innovation you've heard about, it's real, it's here, it's in use in the field, it's ready. And the second is that the pace of regulatory and policy change is not keeping up with that innovation, and that we all need to impress upon governments, regulators, policymakers, and funders a sense of urgency that the challenges we're facing around malaria are winnable, but if we don't move fast, some of these challenges will become much more difficult to contain. And that if we can get the harmonization, the synchronization of the regulatory and policy and funding decision makers, if we can get everyone on the same page, we can advance these and other technologies to the field faster and save hundreds of thousands of lives. So thanks to all of you for joining us. We wish you a good day. We'll follow up. We'll share this recording on our Malaria No More YouTube channel. And if we have a chance, some of the questions we didn't get to, we'll send to our panelists and perhaps they'll be able to post answers to them as well. Thanks to our panelists and thanks to all of you for joining us.